Hello there, geometry folk. Today we are learning about three-dimensional figures. We are in chapter 1, section 7, and I should let you know that we are at the end of the chapter, so you should be expecting an exam soon. But before we get started today, I need to make sure that we all have the same terminology or vocabulary as we talk about these three-dimensional figures. And so we have a diagram on the right that you can see some of these things in their verbal description here on the left. And so you can see here, trying to get that little cursor out of the way. A polyhedron is a solid with all flat surfaces that enclose a single region of space. A face is a flat surface of a polyhedron, but it's also known as a polygon. So what I mean by that is that you can see here the faces are all the flat surfaces of this figure. And so when you look at the shape of that flat surface, in this case it happens to be a trapezoid. So all of those flat surfaces are going to be in the shape of a polygon. So if you know what polygons are, like quadrilaterals, hexagons, pentagons, all of the faces will have the shape of a polygon. Okay, and then edges are the line segments where the faces intersect. And then a vertex is the point where three or more edges intersect, and we can see that in the diagram. So to continue with some of this terminology, we have another diagram here for you to write down all of this stuff. You might want to pause the video at this point and write all this stuff down. But these are different types of solids. So I want to give you some of those. Prism is a polyhedron with two parallel congruent faces, and we call those parallel congruent faces bases. So you can see here base on top, base on the bottom. So we're saying that there are two parallel. So you know what parallel means. It means that they're never going to touch. So the top of this prism and the bottom face of the prism are going to be parallel, so they're never going to be touching. So those two parallel congruent faces are called bases. And then those bases are all connected. So here's the connections. They're connected all the way around by the parallelogram faces. Okay, so all of the faces, all of these faces that are going around the solid are parallelograms themselves. So what they mean by that is these are parallel, that's parallel. So this quadrilateral, this rectangle, if you will, is a parallelogram. Okay, so that's what a prism is. Then we have a pyramid, and a pyramid is a polyhedron that has a polygonal base and three or more triangular faces that meet at a common vertex. So notice that the base of the pyramid is, in this case, a rectangle. It's got four sides. Okay, but you can have different polygonal bases. So it could have been a hexagon base, and then each of those sides of the hexagon would have a triangle face coming out of it, meeting at a point which is the common vertex. So there's your pyramid. And then we have things that are not polyhedrons. We mentioned this, we talked about in the previous slide about a polyhedron has to have all flat surfaces. So what's happening here is that all flat faces, right? So this is not flat. So basically you have a flat top, a flat bottom, but the surface around is not flat. This is like a circular. So we have a, for example, I have here my hydro flask. This would be an example of a cylinder. So flat surface down here, flat surface even up here, but the around part is curved and not flat. Okay, so there's your cylinder. A cone, very similar. I'm sure you've seen these before. We have cones that you see on the road, cones that people put on their heads for like party hats. So again, not all flat surfaces. The bottom is a flat surface, but the rest of this looks like a triangle, but it's not a triangle. It's actually, I can take a piece of paper and make a little cone out of it. Sure you've seen this happen before, something like this. So again, it's not flat, it's circular around. So a cone is a solid with a circular base connected by a curved surface to a single vertex. So there's a cone, not a polyhedron, but it is a cone. And then you have a sphere. A sphere has nothing that is flat about it. So it's the set of points in space that are the same distance from a given point. A sphere has no faces, no edges, no vertices. So these are all examples of, these bottom three are examples of what is not a polyhedron, and the top are two different types of polyhedron that we'll be talking about in a bit here more. So let's go to our next slide here. And what you see here is that polyhedrons, when it is a polyhedron, then they can be named by the shape of their bases. So because this is a base that is a triangle, see this base here is a triangle, and I don't know if you're thinking to yourself, why isn't the bottom part the base, because you think base bottom, but remember that the definition was that the bases had to be parallel to each other. So because the bottom is a four-sided shape, there's no parallel four-sided shape above it to make it be the parallel, top and bottom kind of idea. So in this case, your bases are actually like on the sides, and so you have the front here, which is a flat triangle, and the back flat triangle, and those two faces are parallel to each other, and therefore this is actually named by its base, and since the shape of the base is triangle, it's a triangular prism. Here, all of the faces are rectangles in this case, but nonetheless, the bases are also rectangles, whether you look at it top, bottom, or front, back. It's going to be a rectangle because the shape of the base is a rectangle, so rectangular prism. And in this case, we have a pentagon. So again, the two parallel bases are the top and the bottom in this case, but you can see here 1, 2, 3, 4, 5 sides. That's a pentagon, so it's a pentagonal prism. And then we have a triangular pyramid. This is not to be confused with the prism, because remember the prism has those two parallel bases, and the triangular pyramid only has one triangular base, and then all of the sides are meeting at this one common vertex, which is not happening in the prism case. Then you would have a rectangular pyramid, which now has a base that is a rectangle, and then a pentagonal pyramid where the base is a five-sided pentagon. Alrighty, so we're going to go to our first example now, if I can make sure that this little guy works. Lovely. And it's going to be quite the workout here. Let's see if we can get this out of the way there so you can see that. I'm going to change the sizing of my font because I'm going to write on this little guy, and there's a lot to write. So let's kind of pull this guy out of the way for a moment right now. It says, determine whether each solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, the faces, the edges, and the vertices. So that's 4 different things that we have to name if it is in fact a polyhedron. And lo and behold, for part A, we do in fact have a polyhedron. The solid is formed by polygonal faces. So all of the faces of this solid are rectangles, right? So they're all rectangles. So because all the faces are in the shape of a polygon, then it's met that requirement of the flat surfaces, and they're all polygonal faces. There are 2 parallel congruent bases. So we also have, well, since all of the faces are rectangles, it doesn't really matter which one you consider the bases, but they are parallel. So the top base and the bottom base, or the front and the back, or the left and right, I'm not exactly sure how do you want to name those, but any way you look at this, you're going to have these rectangular faces everywhere on all sides. So this guy is going to be what we call a rectangular prism. So it's said to determine whether each solid is a polyhedron. So in this case, the answer is yes. And then it says to identify the solid. So we're going to identify it as a rectangular prism for the reasons mentioned. And now we have all kinds of stuff to do, and we want to name the bases. So let's start here with bases. I hope we have enough space for all this loveliness. But we have bases, and I'm just going to go ahead and do what the easiest thing is to just call the bases top and bottom. There's no reason not to. And so if I talk about the bottom base, I'm going to go from here M, N, O, P, and it is a quadrilateral, a parallelogram, so I'm going to write a symbol for parallelogram, and then I'm going to write the letters M, N, O, P, that's one base, and then the top base is going to be also a parallelogram, so we're going to write that little symbol down, and then we're going to go R, S, T, Q. R, S, T, Q, and that is how we get our bases out of the way. And then we have to do the faces. So keep in mind that all of the faces are also parallelograms. So now we're going to go to the faces. Now remember, you don't have to put them in the same order that I'm putting them in, but we have to make sure that we get all of them. So we already took care of the top and the bottom. So now we have to go all the way around, including the top and the bottom. So we have 1, 2, 3, 4, 6 different flat surfaces. So we are going to need to put 6 answers. So even though you already called MNOP and RSTQ bases, you have to list them again as faces because technically bases are faces. They're parallel faces. So we have to list them again. So we're going to go MNOP, parallelogram RSTQ, and then let's just hope we don't forget anybody. Remember, we need 6. Let's make sure that we don't repeat the same ones, but we did the top and the bottom already. So I'm just going to go around the solid. So I'm going to start with this front face. So I'm going to call this parallelogram. We have 4 more to go, right? So we're going to go P, Q, T, O. And then we're going to have parallelogram. Now I'm going to the side one here. We're going to go S, N, O, T. That spells snot. And then we're going to go to this back one, R, M, N, S. R, M, N, S. And then finally this side one here, we're going to call that R, M, P, Q. R, M, P, Q. I do want to stress that, as you saw me doing that, when you are naming planes or flat surfaces like this, you need to always name them in a circular order. It doesn't matter where you start. So I could have, for example, let's go with the MNOP base, okay? I could have started naming that by starting with N. And I could have gone NOPM, or I could have gone backwards, NMPO. But you always want to go in a circular motion, either clockwise or counterclockwise. But what you don't want to do is go zigzagging. So for example, I wouldn't want to go MONP, like zigzagging across. You always want to, wherever you start, so if I start an O, I'm either going to go clockwise, so OPMN, or counterclockwise, ONMP, if that makes sense. So as you're naming those faces. Now, the last thing we have to do for this part is the edges. And that's going to be fun because I believe that for this figure, there's going to be about 12 of them. We're going to have to do all the edges, so all of these corners here, there's 4 of those. And then we're going to do top and bottom here, top and bottom there, top and bottom there, top and bottom there. So 2, 4, 6, 8, and then 4 corners is 12. So let's hope that that can help us as we go through and get all these in, okay? Now they are edges, so we want to make sure that we use the symbol for a segment because they have 2 endpoints. So make sure that you're using the right symbols everywhere. So we're going to start with the 4 corners around. So I'm going with these vertical ones. So we're going PQ, and then OT, and then NS, and then MR. In addition to those 4, we're going to do top and bottom, for each side. So we're going to go QT. That sounds like cutie pie. And then PO. And then we're going to go to this one up here. So it would be ST and NO. That spells no. And then we're going to go to the back. And we're going to go RS and MN. And then we have two more to go, which is right here. So we're going to go RQ and MP. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. And so we're good with that. So after all that, we are finally done with part A. Lucky for us, in part B, if you're thinking, oh my gosh, we're teaching enough space, it's okay, because when you look at part B, the first part is determine whether each solid is a polyhedron. This one is not a polyhedron. And the reason why it's not a polyhedron is because it only has the two parallel faces, but the surface area around is a curved surface. Remember we said that for a polyhedron, all of the surfaces have to be flat. So you don't have a flat surface for this solid. It has a curved surface. So this one is actually a cylinder. They didn't ask us to identify, actually they did. It says determine whether each solid is a polyhedron. So no, it's not a polyhedron. Identify the solid. It is actually a cylinder. A cylinder. And then when it says if it is a polyhedron, well, it's not a polyhedron, so we're not going to name the bases and the faces, and so we're not going to have, we're not going to run into any space problems here. We're good. Okay, so now we're going to go to part C and do the same thing. So now we're looking at this little guy, and we're trying to determine whether it's a polyhedron or not. All flat surfaces. The bases are all triangles, looks like. But what we don't see is two parallel faces. So in this case, it is a polyhedron, but it's not going to be a prism like part A. It's going to be a pyramid. So now we have a triangular pyramid for this little guy. So I'm going to come over here and write triangular pyramid. Hopefully you can read my writing there. But we have a triangular pyramid. And then we're going to go and do the same thing that we did over here. Now with the pyramid, you only have one base. So that's kind of nice. So we're going to come over here. And we're going to name our base. We're just going to go with the bottom one. And I just realized that it looks like my diagram here is missing a letter. So that letter should be a C. So it kind of got cut off there. I apologize. So I'm going to call that my base. And since my base is the shape of a triangle, the base here is going to be triangle. See here we used a quadrilateral symbol or a parallelogram symbol. Here we're going to use a triangle symbol. Triangle ABC is going to be my base. And then we want to go with bases. I was supposed to do that in orange, my malo. Let's fix that real quick like. I like to be consistent with this stuff. Oops. Bear with me here. Let's go back to pencil. And then we wanted to go here and we said triangle ABC. And then we're going to go to faces. And for the faces, remember that the base is also considered a face. So we're going to rewrite triangle ABC. For this pyramid, there's actually 4 faces. There's the 3 faces that are going around and the one on the bottom. So we have triangle ABC. And then we have this darker shaded one up in the front is triangle CBD. Triangle CBD. And then we have in the front here triangle ACD. And then lastly we have the back triangle, which is going to be triangle BAD, which kind of spells triangle bad. That's kind of cool, huh? All right. So now we want to do the edges. So I don't know if I'm going to have space for that little guy. And I just realized I forgot something. I'm going to have to go back and fix it. But edges here are going to be BC. I'm going to start with the base first. It's just easier for me that way. So I'm going to go BC, BA, and then AC. And then we're going to go with the ones that are standing up or vertical-ish. So we're going to go AD, DC, and BD. So AD, DC or CD, and BD. Like that. So you have 6 edges for this figure. And then the last thing that I actually forgot to do in the other one is vertices. I guess I forgot vertices. I just realized that right now. So I'm going to have to add vertices over here. Please don't shoot me for that. And so we need to do that, little guys. So for vertices here is going to be pretty simple. The 4 vertices are A, B, C, and D. Point A, point B, point C, and point D. And then for the part A, which we forgot, just got to do all the ones that are labeled. So we got to go Q, P, O, T, N, S, R, and M. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Sorry that I forgot to do the vertices for part A in the beginning, but that will actually conclude this one example. It took forever, but don't worry, the rest of them won't be so long. So there's that little guy. So I am now going to give you your DIY. So I need to delete this stuff real quick. And then we're going to go back to this. And then we're going to go, sorry, this is quite the process here. So here's your DIY, and then we're going to go on to bigger and better things. Yay! So we're going to go here, and now we're going to talk about a regular polyhedron. So for a regular polyhedron, you have to, a regular polyhedron is a polyhedron that has all of its faces regular congruent polygons. We talked about regular in the previous lesson. Regular means that all the sides and the angle are the same. So for a regular polyhedron, all of the faces have to be regular polygons. So here we have some examples of regular polyhedron. They're the basic Platonic solids that they're named after Plato, Platonic, because he used them exclusively. But we have a tetrahedron, hexahedron, octahedron, dodecahedron, and the icosahedron. So those are those little guys. And what we're going to be doing is we're going to be taking these figures and some like them, and we're going to be finding the surface area and volume of these figures. But lucky for you, we have formulas for this stuff. So make sure that all of this stuff is in your notes, because I don't expect you to memorize it all, but I do want you to know how to use it. So just keep in mind, here's the figure. It will kind of help you see what the variables represent. So see here, you see P, you see all this red. P is for perimeter. So down here is like a key. So it'll tell you that P is the perimeter of the base. So as I'm trying to find the surface area, which is what the S stands for, of the figure, I need pH plus 2B. But if you don't know what P is, you're going to have a problem. So P is the perimeter of the base. So if you know what the base is, you can find the perimeter of the base, times that by the height, and then add 2 times B. Well, what's B? B is over here. It's the area of the base. So there's all these formulas, and so I need you to make sure that you know what all these letters are. If you don't know what the letter is, it'll either be down here in this area in the key so that you know what it is. All right? So we're going to do that, give you some time to write that down, and then we're going to go to example 2, where they're asking me to find the surface area of and volume of this square pyramid. So in order to do that, I need to have the formula, which was on the previous slide, but I'm going to write it down here again, just for our viewing pleasure. So we're going to have surface area equals 1/2 perimeter times length plus B. This is the formula from the sheet that we just saw in the previous slide. Okay, volume is equal to 1/3 B times H. Okay, so notice that the H is right in here. This is the 4 centimeters. That's the height of the pyramid. But this 5 is the L there, the length of the triangle face. Okay, so as I do this, I'm going to try to plug stuff in. So we're going to go here and say, okay, so according for this one, this is the first thing we're going to do. We're going to say surface area is equal to 1/2, and we need perimeter. So before I can plug in perimeter, I need to figure out what the perimeter is. But this is a square pyramid. So because it's a square pyramid, the bottom is a square. So the perimeter is going to be 6 times 4. Right? So 6 times 4 is going to be 24. And so when I come over here, I'm going to plug in for P 24. Then I'm going to times it by L, which we know is 5 from the diagram. And then we're going to add B. And remember that B is the area of the base. So again, over here, for B, that's the area of the base. And since again, the base is a square, it's going to be 6 times 6, or 6 squared, which is 36. So in the place of B over here, we're going to add the 36. So now we're going to get half of 24 is 12, and 12 times 5 is 60, and 60 plus 36 is now 96, and this is surface area, but it's still area. The units were centimeters, so it's 96 square centimeters for the surface area. Now for the volume, we're going to go with 1/3 B. It's the same B as before, so it's still going to be 36 times this time H, not L, but H, which was the 4 here. So now we're going to get 36 times 4 divided by 3, which is actually 48. And this time our units are cubed. So remember, with volume you are doing cubic centimeters or cubic units, and with area you are doing square units. All right, so that is how you do that little guy. And now we're going to let you go to your DIY question, which is right here. And then we're going to go on to our last example. Our last example is right here. And it says the diameter of the pool Mr. Sato purchases 8 feet. The height of the pool is 20 inches. Find each measure to the nearest tenth. Now the problem with this is it seems pretty simple. There's two things going on here. First of all, they want the surface area of the pool. To get the surface area of the pool, remember that you don't need to include 2 bases. Normally you have 2 bases, but the top of the pool is open, so you only want the bottom base and then all the way around. That's one issue. Second issue is that you've got dimensions that are in 2 different units. You have 20 inches and 8 feet. So the first thing you have to do is take those 20 inches and convert them to feet. So to do that, you're going to take 20 inches and convert it. So I know that there are 12 inches per foot. So it turns out that it's 5/3 feet. 20 inches is the equivalent of 5/3 feet. So using that measurement, we are going to do the problem. So again, first thing we need to do is have the formula. But remember, we're going to modify the formula just a little bit because we don't need, so surface area is equal to, this is again from that page that I showed you earlier, 2 pi RH plus normally 2 pi r squared. But since we only have one base, we're not going to put 2 pi r squared. We're going to put pi r squared, just 1 pi r squared, because the pi r